So now we're going to move on to combinations. Combinations are very similar to permutations. Okay, and the definition is going to look very similar as well. It is the selection of R objects from a group of N objects where order is not important. And underline that. So the difference between a permutation and a combination is permutations are when order is important. Combination is when order is not important. And so going into that screen that we used before, you probably are familiar with seeing that NCR. And that's what we use here with combinations. So the problems are going to be set up the same way, only it's going to be a C instead of a P. And so over here we'll write our functions that we need to use in the calculator. They're going to be the same functions where you press the number. So our first number is 8. Then you're going to go math to PROB. And this time we're going to select the option that says NCR because it's a combination. And we type in our second number, which is 3, and hit enter. And we get 56. A lot of the questions in the permutations and combinations, more specifically in combinations, refer to using cards. And you're going to see we're going to be doing probability soon. And in probability as well, they like to use cards and dice in their questions, so you kind of need to know a little information about a standard deck of cards. If you have questions about a standard deck of cards, please ask the substitute to help figure it out with you, okay? How many different suits there are, what are the suits, how many different face cards, what colors there are, how many, okay? I'm just going to give you that information in this packet here, but if you don't know, you need to make sure that you learn the kind of characteristics of a deck of cards. A standard deck of 52 cards, so a deck of cards has 52 cards in it without the jokers. If the order is not important, so they tell us it's a combination, how many different 7-card hands are possible? So out of the total cards of 52, we want the combinations for 7 of them. So in our calculator, once you've typed it in, remember you could do that second enter, and it'll bring up what you had typed in before, and you just have to change the numbers. And so we get 1, 3, 3, 7, 8, 4, 5, 60. Okay, so that's how many different hands are possible. So now it says, of how many of these hands have all 7 cards of the same suit? So here we have 2 different things that we're talking about. First of all, we're talking about cards, 7 cards of the same suit. But first we need to talk about how many suits there are. If you know some things about a deck of cards, you know that there are 4 suits: hearts, diamonds, spades, and clubs. So there are 4 suits that we have. We want all the same suit, so we're going to choose one of those suits. If we take our 52 cards and we divide it by 4, we know that there are 13 cards in each suit, and we want to choose 7 of them. So here, this is also uses the fundamental counting principle, because first we have to figure out how many suits there are, then we have to figure out how many different ways could you make a 7-card hand, and then we're going to multiply those 2 together to see how many they can happen at the same time. The fundamental counting principle that we went over just before. So we can plug this in individually, so we can type in the first one, get a number, times the second one, Or if you want, you can go ahead and plug in it all at once, okay? But you would have to do a little bit more work there because you'd have to go back into that math probability screen to bring up the NCR again. So we're going to multiply this by 4, and we get 6,864 different hands. Question 2 says you are taking a vacation and you visit as many as 5 different cities and 7 different attractions. The question says, suppose you want to visit exactly 3 different cities and 4 different attractions. How many different trips are possible? So, again, this uses fundamental counting principle because we're talking about 2 different things. We're talking about cities and then we're talking about attractions. So, how many cities do we have to choose from? We have 5 cities to choose from. And we are going to choose to go to 3 of them. So it'll be 5, choose 3. Okay, or combinations of 3. Then we have 7 different attractions to choose from, and we want to go to 4 of them. So we'll find out what both of these are. So we get 5, C3, we get 10 times 7, C4, and we have 35 of them. 10 times 35 is 350, so it would mean that we have 350 trips. The next question says, suppose you want to visit at least 8 locations, cities, or attractions. How many different types of trips are possible? So in part B, it's just saying that we want to go to 8 places. It doesn't matter if it's a city or if it's attractions, all cities, all attractions, whatever. Okay, so what we need to do is figure out how many locations we have altogether. So what we're going to do is take that 5 and 7 and add them together, and 5 plus 7 gives us 12. And out of the 12 different places that we could go, we want to choose 8 of them. So 12C8, which gives us 495 trips. Now, if you had read ahead, you would see that question number 3 is missing something really important. It says a restaurant offers salad toppings, but it doesn't tell you how many salad toppings. So I want you to write in here that they offer 6 salad toppings. On a deluxe salad, you can have up to 4 toppings. How many different combinations of toppings can you have? And then in question number 4, it says the committee of 5 people is to be chosen from a group of 20, 12, and that should be of which, not of which, are men and women. 8 are women. Okay, and then part A asks if the order in which they're chosen is not important, how many different 5-people committees are possible? Then part B, how many different ways can 3 men and 2 women be chosen for the committee? So I want you to pause the video now and try questions 3 and 4 on your own, and then come back when you have finished with these to check to see if you are doing these correctly. So question 3 said you had 6 salad toppings to choose from, and for each salad you can have up to 4 toppings, so 6C4 was 15. And I'm just going to say combos here because there's 15 different combinations of toppings that we could have. Question 4, the first one said, in the order in which the people are chosen is not important. How many different 5-people committees are possible? So here, it doesn't matter if it's male, female, nothing. So we have 20 people altogether. And we're going to choose 5 of them for our committee. So that makes 15,504 committees. Part B says, how many different ways can 3 men and 2 women be chosen for the committee? So now we're broken up between men and women, so this is where we're going to have 2 pieces be multiplied together. So out of the men, there are 12 men altogether, so 12C3, because I'm going to have 3 of them, times there are 8 women, so 8, whoops, that was supposed to be a little 8, C2. So 12C3 gave us 220. 8C2 gives us 28. So 220 times 28 is 6,160 different ways.